cultural evolution. But his criticism really sunk in, and in the 60s, in the 70s, people kept rolling with this, and they realized, we actually weren't applying Darwinism at all when we were using this word cultural evolution. Darwinism tells us that there's these branching patterns, culture split, uh, that species split, and culture should split too if they're actually evolving in a Darwinian fashion. And so it's actually inappropriate to say that one culture is ultimately like the right one or the best one or the one that all other cultures are aiming at. Instead, we have this diversity of cultures that work in different ways. And just like species, some can end up becoming so successful that they dominate and destroy a bunch of other cultures, which is something that we've seen Western cultures do. They'll just take over, and people will either assimilate or go extinct. But he started looking at culture as a branching pattern more appropriate to Darwinian evolution. And this gave rise eventually to what we call cumulative cultural evolution. And if you want to look up this field of research, it's an entire field of research today. That's the key word you're going to want to use is cumulative cultural evolution. And that'll get you to the papers and the experiments that we're doing today. This is a process extremely similar to biological evolution with one slight change. And this actually might be where the apparent disagreement between us lies. We actually might not disagree as much as it seemed on Twitter, which go figure. But biological entities, they evolve through descent with modification, acted upon by selection, and so do cultural entities. When I say a cultural entity, I mean it could be a single idea, a single invention. The igloo, for example, has changed over time. The way that it's used, the spears that the indigenous people are using, they change in the length of the handle and the tip of the spear and so on. These change over time, and we can see these when we study anthropology. We can see these changes, and these really do reproduce and change in a way strikingly similar to biology. So in biology, how does modification come about? Well, sometimes we have random accidents. So genetic damage can cause a mutation in DNA. You can have a random copying error, which is also a way that modifications occur in biology. You can have a merger, which is what happens with sexual animals. Genes that have evolved in one lineage can merge with genes that evolved in another lineage through sexual reproduction, and you get novelty that way. This also happens in bacteria through horizontal gene transfer. There are also outside agents that can cause novelty to form inside of a genome. So when a retrovirus infects a victim, it inserts its genome into their genome. We can actually see that in mammals, in placental mammals, at least several genes that come from viruses were actually co-opted into our genomes and are actually an important part of the placental formation. So this is not a random mutation. This is a virus infecting an ancestor, and then that mutation that occurred from that, the viral genes ended up being co-opted by those ancestors, and today they're actually useful for us. So there are many ways that modification happens in biology, and the exact same things happen in culture. So you have random accidents that invent new things in culture. I've got a list here of inventions that were accidentally invented. You've got copying errors that cause new inventions. I'll talk about some of those in culture too. You have mergers of ideas. You have outside actors. So chocolate is something that we see as candy today, and was something that cultures were using as food a long time ago. And people trying to make alcohol out of chocolate helped the chocolate processing. People who wanted to use it for food actually started fermenting it for 4 days, because if you ferment chocolate for 4 days, it takes away a lot of the bitter taste. And so you have these outside actors interfering, and then the other groups that were using that end up using that to their advantage as well. You see all of these exact same things in biology. You see them in culture. the difference, the thing that's added on top that really helps cultural evolution take off quickly is that on top of all those other things, you've got insight and theory, which helps us, evolution, biological evolution is a trial and error process. So is cultural evolution for the most part, but there's also this thing called insight and theory, which we can actually apply insight and theory, and it's like a shortcut. We don't have to do trial and error on everything. We can dramatically speed things up, and this is one way in which cultures evolve, but it's only one. And there is actually arguably some processes in biology that are very similar to that. So somatic hypermutation, some people are trying to argue now is similar to the application of insight and theory in a cultural sense. This is how our immune system adapts to new pathogens, is through somatic hypermutation. That would take us in a whole nother argument if we kind of went down that rabbit hole. But just a quick list of things that were invented through random mutation. You have safety glass, LSD, Vaseline. The entire field of organic chemistry got started off because of an accidental discovery. Penicillin was an accident. Saran wrap. Patapuri it's the most popular cheese in Brazil, most popular cream cheese. And it was a mistake. Someone was trying to make cream cheese and they screwed up. It was a copying error, a random copying error. The microwave oven, potato chips, and corn flakes, all of these things were accidental discoveries. Random mutations essentially generated these in the world of ideas. So descent with modification happens in almost exactly the same way. The only addition really is this addition of theory that we can also use to help us shortcut some of the trial and error. And then selection works almost the same way too. So in biology, selection, if we're asking, we're asking, does the mutation that occurred, does it increase the survival or reproduction of this biological entity within the biosphere? If it does, then it's being selected for. If it does not, then it's being selected against. And in culture, does the mutation increase this idea or this cultural entity's survival or spread within the mindosphere? So instead of the biosphere, you've got this mindosphere. And the spork is one example of that. Where we use sporks in prison instead of knives and forks because they're harder to make weapons out of and they're cheaper. You just need one thing instead of two. There's a great book that I highly recommend people reading if they want an overview of the actual scientific field of cultural evolution, and that is by Joseph Henrich, and it's called The Secret of Our Success: How Culture is Driving Human Evolution, Domesticating Our Species, and Making Us Smarter. That book is a wonderful overview of this whole process, and in it, one of the most applicable sentences of this book would be, over generations, often outside of conscious awareness, individual choices, learned preferences, lucky mistakes, and occasional insights aggregate to produce cultural adaptation. And I suppose I can just stop there for now and see what Francis has to say.
So, Jeff?
I don't strongly disagree with the mass of things that were said here. I agree with 99%. Those are beautiful parallels to make. But sometimes I have the impression that human culture is treated as if we were to try to determine if I'm in face of a functional car, for example. And human culture has the motor, it has the wheels, it has the brakes, but there's one thing missing. There's the transmission isn't there. And therefore the car, no matter all parallels that you could do with that car, it still not is a functional car because it's missing an essential element. And the essential element with which I strongly disagree with John here is the idea of random mutation. I've heard heard a couple of examples in what you listed. LSD. Okay, LSD itself was not desired. It was not aimed by the individual to create LSD. That being said, LSD was developed by a curious creature, a creature that had evolved to be curious, to be digging, to be searching for things. And this ended up creating a context in which this particular accident happened. And even when the accident happened, then there were certain features of the brain of this individual who dropped a drop of LSD by accident in his mouth. And there were certain features of his brains that were already handling this error in certain ways and not other ways. So I would ask to just to clarify, because I consider that these things are not random mutations of human culture. I consider that they are actions of the human brain in the world, and the human brain having already evolved to prefer some things. I don't see the consequences of the human brain creating LSD or creating some sort of cheese, whatever it is. I don't see them as random consequences in the world. To the contrary, I note that what we create are food items. Well, we've already evolved to like food. We've already evolved to be curious. We've already evolved to learn from trial and error. To that extent, those are not as random as the little letters of DNA that get transformed in our DNA. And the great wisdom of Richard Dawkins was to find the right words to put on this distinction between what is a cause of the genes and what is a gene. And he ended up using the word replicator to create the new category of things he was talking about. And to me, the most insightful insight that we got in biology from any theory was this dichotomy between the genotype and the phenotype. So I would ask to John, do you consider that human culture is a replicator in the Dawkins sense of the word? And how do you see this genotype interacting with the DNA genotype? Do you consider that the human brain is a phenotype of human culture? Do you use these words, or do you not care about this distinction?
Well, I would say so. Like a spork is a phenotype, and the idea of a spork is the genotype. Uh, the the I mean, Richard Dawkins actually laid this out quite clearly with his concept of memes. Just a little side note: memes haven't the word meme is actually not really found in the actual literature very often of cultural evolution, but they use other words in place of that. I mean, Richard Dawkins was an outsider to their field, and it never his terminology never actually took off inside that field. But I actually like the way he described memes better than how anyone in the field has. He describes a meme as the smallest transmissible unit of. Actually, I want to get the actual quote from him. It's a unit of cultural transmission or a unit of imitation. So the he talks about a tire being a meme, the idea of a wheel being a meme. So someone has the idea of a wheel, they build one. Other people see it, they automatically get that idea inside their head, and they can now go build it if they want to. But the actual physical structure of a wheel would be the phenotype, and the idea of the wheel, the meme, would be the genotype.
But then
The
suppose I
memotype.
ask you about the fork. So you have the fork ID. The ID is copied, therefore it acquires the status of a replicator. Then I would agree that the fork itself, the implementation of the fork, is a phenotype. But I want to bring you further there. I want to bring you to the extended phenotype of Richard Dawkins. Is the spoon of let's say, sweet stuff that I put in my mouth and the activation of my tongue through this sweet stuff that I grab with a fork or a spoon, is that the extended phenotype of the fork replicator?
We have uh, we have let me try to. Well, I actually ask your question again because I might be misunderstanding you before I try to
Okay,
answer that.
so
Ask
suppose
one more
that I
time.
recognize that the idea of a fork is a replicator. The fork
Mm-hmm.
itself is the phenotype of this replicator, which has passed through generation through some mechanism. Now I'm asking about the extended phenotype of the fork. And suppose that I grab some sweet material, put it in my mouth, and then I feel on my tongue